In this tutorial, we're going to talk about lines in the coordinate plane. And a coordinate plane is very simply a grid with X and Y. It is what you have been using your entire school career. It's with an X and Y. And what we have in this picture is a linear function. And I know it's a linear function because it is a line. Now there are 2 points plotted here, which should be pretty easy to tell what they are. This point here is at -1, -1, and this point up here is at 0, 2. I know it's not directly on the line, but that's what I intended. So we have a couple different ways of describing a line, and the first way is called slope-intercept form, which you should already be familiar with. This is y equals mx plus b. And in y equals mx plus b, m always stands for the slope, and b always stands for the y-intercept. And y-intercept is very simply where this line, this blue line, intercepts the y-axis. So if I were to create a function for this line in particular, I first need to determine my slope, which is rise over run. If you don't remember, we can write that up to the side. If you don't remember this, make sure to write it down. Rise over run, how much I go up over how much I go over. So I'm going to start from the point farthest to the left, and I'm going to see, if I follow the grid lines, how I'm going to get to this next point. So I start here and I'm going to go up 1, 2, 3 units. So my rise part here is going to be 3 over, now how much do we need to go to the right? Well, I need to go over 1 unit. So 3 over 1 is my slope. And we need our variable x, and then plus whatever the y-intercept is. So this function looks like it crosses the y-axis, I should say. So where this line intersects the blue line, which should be here, right at this point, which is at y equals 2. So in a more cleaned up, simplified version, my slope here, or my equation of this line is y equals 3x plus 2. Just like so. Another form that we have to help us with linear functions is something called standard form. And standard form looks like this. ax plus by equals c. And the reason why this can be helpful is if we happen to get really nice intercepts, and that makes graphing the line very easy. But we really won't see this that much. So let's take a look at an example. We're going to graph the line of 6x plus 3y equals 12. So the way that we do this is we take it in turn. We first want to determine one of the intercepts, either x or y, and it doesn't matter which one. But what I do want to make sure that I do is that I have everything right where I want it to be. So this 6, oh excuse me, I wanted to write that as red. This 6 represents the x-axis because it's right next to the x variable. And the 3 represents the y-intercept because it is right next to the y variable. And 12 is a constant, and it does play a part. So the way that we solve for the x-intercept is by setting y equal to 0. In other words, we want to pretend like that y term isn't even there. So if I take away the y term altogether, I have 6x equals 12. And how would I solve for x here? I would simply divide both sides by 2, or by 6, I'm sorry, and that gives me x equals 2. That means on the x-axis, where x is equal to 2, is an intercept. So I'm going to make that point right here, nice and big and red. Now, in order to find the y-intercept, I'm only interested in the y term, so I'm going to set x equal to 0 and that's just going to give me 3y equals 12. And I'm going to solve this equation the same exact way as I solved before. Divide both sides by 3. And I have y is equal to 4. So up on the y-axis, I'm going to make 4 a point, nice and big and bold. There we go. Now that I have my two intercepts in place, I can connect them like this to make my line. And that's how you use standard form. Another form that we have is something called point-slope form, in which we need to know the point and a slope to write. Now, in this form, only the colored variables are going to be substituted. We need the x and the y that are black to keep their place value for those variables when I'm done with my equation. I can't just have a bunch of numbers equal to each other. I have to have something like y equals something x, blah, blah, blah. I can't just have numbers everywhere. So that's why we leave this y and this x all alone. They're not going to be replaced ever. So let's take a look at an example on how to use this. So here's our example. It says, write an equation of the line through the point P, negative 1, 4, with slope 3. Now, since I'm given a slope and a point, it's wise to use point-slope form, because that's what I know. So I color-coded everything exactly how it should be in point-slope form. Now, all I have to really do is substitute everything where it belongs. So the first y, like I said, stays right where it is. I'm going to subtract whatever y1 is, which is 4, equals, and then my slope, which they said was 3. No solving involved here, which is nice. And then x minus x1. Now, when I write a negative 1 here, please remember that when I subtract a negative, when I've got this business right here, this whole thing becomes a plus. Because when you have two negatives, it makes it a positive. So I'm going to write a plus sign here instead. And that is all I need to do. If I'm writing an equation in point-slope form, I can stop right here. That is my answer. All right, let's take a look at one more example. All right, so here, let's take a look at this example. It says, write an equation of the line through A, negative 2, 3, and B, 1, negative 1. Now, in order to use point-slope form, remember that I need to know a point, which I have two of to choose from, and a slope. But I don't know a slope right now. So can you think of a way to find a slope between 2 points? And if you said slope formula, you would be right. So I'm going to write it out to refresh your memory. And here it is. So now, when we use this, we need to make sure that we carefully select our x and y values. So since A is my first coordinate, this is going to be x1, and 3 is going to be y1. And for point B, the 1 is going to be x2, and negative 1 is going to be y2. Alright, so now we just have to plug in to this formula. So y2 is negative 1, minus y1, which is 3, and this is all over x2, which is 1, minus negative 2. And now we're going to clean this up. So negative 1 minus 3 is negative 4. And remember that here I have two negatives, so that means it becomes a plus. Okay, so 1 plus 2 is 3. So negative 4 over 3 is going to be my slope. So I'm going to make sure I make a note of that right now. So this is what m is equal to. Okay. All right. Now we have my slope, and I've got 2 points to choose. And you can choose either point that you like, because they're both on this line. So I'm going to set up my point-slope form. I have y minus y1. And I'm going to choose point A, just because. And I'm going to write out minus a positive 3, because that's y1. and equals my slope, which is negative 4/3, parenthesis, and then x minus x1, which is a negative 2. So now I'm going to do one more step and just clean it all up. So y minus 3 equals negative 4/3 times x plus 2, because there are two negative signs. And this is going to be my final answer. And that concludes this tutorial.